Okay, so in this problem, the key thing that is given to us is we are given n, which is number of vertices. We are also given degree of each vertex, and we have to tell whether the given graph is tree or not. Now, what essentially we can do is we can try to figure out what is the correlation between degree in a graph and a tree, right? That's one way of looking at it. We look at the graph property and does it match the tree property, or we look at it from the other side. If we are given any tree, imagine there is a tree, let's say there is node 1 here, 2, 3, 4, and keep in mind this is not talking about only binary trees. Tree can be anything. So it can be like a tree with these nodes, or it can be a tree where let's say there are 2 more nodes, 5, 6, 3 has 1 child, 7, and 4 has 4 childs, which 4 children, 8, 9, 10, and 11. Now in this tree, one thing to keep in mind is if there are 11 nodes in the tree, 11 vertices there in the tree, the number of edges in the tree will always be 1 less than this. And you can do that count. Essentially, this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, and 10. There will always be 1 less number of edges in the tree. This is n is the vertices, and edges that we are seeing is 10. Now, if that is the case, if edges are 10, then what will be the sum of degrees of each vertex? Now, degree means how many edges are going or are connecting to this vertex. So 1 is having a degree of 3 because this is one edge, this is another edge, this is another edge. So 1 has a degree of 3. 2 has a degree of 3 because 2 has 1 edge this and 2 edges this. 3 has a degree of 2. 4 has a degree of 1 edge above and 4 below. So this is 5. So essentially, if you look at, if we keep on adding, 5 has 1 edge, 6 has 1 edge, 7 has 1, 8 has only 1, 9 has 1, 10 has 1, this has 1. So overall, if we see 1 plus 1 plus 1 plus 1, so this is 4, 3, 7, 7, 5, 12, 12 and 2, 14, 14 and 3, 17 and 17, and ideally this is 3, 17 and 3 is 20. So ideally, can I say that each edge is generating 2 degrees, because this, if this is the edge we are considering, this is giving 1 degree to this vertex and 1 degree to the other vertex. So can we say if you add degrees of all the vertices, it should be 2 times the number of edges, right? And that will be a pretty straightforward check that we can have, right? So what we can do is, we are given n, we are given degrees. Let's add all the degrees. Once you add all the degrees, let's say that sum is coming to be s. If that is the case, this sum 2 times, or this sum should be equal to 2 times n minus 1. If that property holds true, we can say yes, this is a tree.